Hello and welcome in. My name is Mark, aka the Markster. Forgive my voice, I'm a little hoarse this morning. This is video number 15 in the FreeCAD series. Today we'll be using FreeCAD version 0.19, revision number 19510. In the last video, video 14, we remade this funnel, which was one that we had originally made in video number 2. In the original model, we made it using 2 cones, and we fused them and used the thickness tool to carve out the interior. And in the last video, we made it using the revolve tool. We revolved this sketch. So go back and watch that video if you haven't seen it yet. Today, we also use the loft tool. I'm just demonstrating different ways to make the same object using the sketcher and the various tools available in the part workbench. So we've used the geometry based method, the primitive based method, constructed solid geometry. Back in video 2, we used the revolve tool. Let's go to part. We use this revolve tool to revolve this sketch in video 14. And we use the loft tool to loft these sketches here. Again, refer back to video 14. So this is really a part 2 or maybe a part 3 of the funnel series. In this video, I'll show you how we can go about using, we can use a sweep tool to sweep around a circle. We could create a sketch with a circle in it to be the path. The path for the sweep tool, which is trivial, but it could be a case where you want not a circular funnel but an elliptical, perhaps to make it fit in a certain for custom use. Maybe a round one just won't fit where it needs to go. So we can use an ellipse for that along with the sweep tool. And we'll just reuse this sketch since we already have it. Alright, so let's go to the sketcher and create our ellipse for our path. When we finish this, we're also going to look at using the extrude tool, because we can extrude sketches at a taper. So that could be used to create this model also. Let's create a new sketch, and we're going to cancel because we don't want any of these options. The reason this comes up, if you have something selected in the tree or in the 3D view, it's going to ask you how do you want to attach it. And I don't want it attached. I want it on the XY plane. I'm going to add a conic section, which is actually what they're calling an ellipse. We'll select the center. And just put it there and there for the major and minor radii. And then we will attach these points using the object on a point on object constraint, and this one as well. Your sketch contains redundant constraints. So this evidently is a redundant constraint. Let's undo that. We have 2 degrees of freedom, which would be the minor radius and the major radius. So we'll set this distance between these 2 points using our horizontal distance constraint. And we'll enter ss.ss as our shortcut. And we're going to use the stem radius. And now we need to set the vertical height of the major radius. We use the vertical distance constraint, selecting the origin and the upper point. You need not select both the origin and the upper point. We could only select the upper point, and that would work too. We'll use the stem radius times 1.5. Then we can come in and adjust this to get a different ratio if we desired one. And we close that sketch. And you can see that our other sketch is lined up appropriately, we hope. Let's go to the part workbench, select the sweep tool. Sketch will be our profile, and we'll select the path in the 3D view. We select the sketch, choose create solid and print it, sweep path, select in the 3D view. We're done selecting our path. OK to do the sweep. So now you see we swept around an elliptical shape. And we can change the ratio. Something a little bit less, maybe 1.25. Did not seem to make a whole lot of difference. Let's mark to recompute, and recompute. No difference. I'm not seeing much difference there. Let's try a different ratio. 0.025. Let's try 1. A 1 ratio would be a circle. That's not looking too circular. Looks like I applied it to the wrong object. Let's delete this. Let's see. Apply it to this one instead. SS.SS stem radius times 1.5. Let me clear out this warning. And now try a different ratio. I leave these mistakes in because we all make mistakes, and learning how to recover is important. Now we have a circular look. Okay, let's now look at how we might make the same model using the Extrude tool. The Extrude tool has a taper option. Unfortunately, one of the limitations, much like the loft tool, when you have an inner wire and an outer wire, the taper function does not work properly. If you're extruding straight without a taper, you can have internal wires and it works fine. But when you have a taper, it does not work properly. So we need to create multiple sketches, as we did with the loft in the last video. So we'll be tapering from the middle section here, a negative taper in the reverse direction, positive taper in this direction. So let's go ahead and set that up. We'll go to the Sketcher workbench, create a new sketch, cancel because we had something selected already. This will be on the XY plane. So we need 2 circles concentric to each other, one representing the inside and one representing the outside. Originally we used the radius to represent the outer radius, and the thickness of the wall comes inside of that. So the radius is the outside radius. So we need to use the outside circle, and we'll use this middle radius for that one. And for this one, apply our radius constraint. Don't need another equals there. Middle radius minus the wall thickness. And we cannot extrude this sketch at a taper because it won't work when you have an outer wire and an inner wire. So what we are going to do is we're going to make this one construction mode, and that's what this icon here does. You see it turns blue. A construction mode element is only seen internally. Any operation external to the sketch, such as extruding or revolving or whatever, lofting, none of those functions are going to recognize a construction mode object. So we can have all the elements that we want in construction mode, and the only one that's going to matter is the normal mode elements as far as tools that we use outside of the sketcher. Internally, inside the sketcher, we can still reference these objects, reference these elements, and many times they're useful for constructing your object, constructing your sketch, and getting all of your constraints the way you need them to be. Sometimes you need some construction elements. Think of it like a scaffolding. You might have a scaffolding around your building as you are constructing it, and then remove those scaffoldings later after all the work is done. With these, we just leave them in here, but they're kind of scaffolding for the construction of the sketch. So we'll close that. This one, let's label this sketch the outer sketch. And we can duplicate the sketch. We don't want to duplicate the spreadsheet. And we'll call this one inner. Then we open it up. We select both edges, toggle the construction mode, and now this one, the inner is normal mode and the outer is the construction mode. Now let's go to the part workbench. And we'll begin with the outer, and we'll extrude it 10 millimeters for now in both directions, +5 and -5 for now, temporarily only. So now we have our outer extruded object, and let's do the inner. Let's not do the inner yet. I'm thinking a way to make it a little bit easier. Perhaps copy the extrude object. Yes. We'll copy the extrude object once we have our angles and things set. And then we'll switch the base that was used to the inner on the copy. You see you have base here. Outer was the base object used. We can change that through this tool, and I'll show you how to do that. But first, we need to figure out the correct angles and the length forward and backwards. The forward and backwards angles are easy enough. That's going to be the top height forward and the stem height backwards. Now we need to work on the angles. So what should the angle be? We could do perhaps the trigonometry and figure out what the angle needs to be for getting the radius where it needs to be at this distance from the center. We could use trial and error and go back and measure back and forth and get it pretty close. But we have a tool at our disposal called the Sketcher that has a geometric solver built into it. So we don't need to switch to the model and hide this for the moment. You can switch back and forth to the model tab and the task tab and hide things that are in your way. We also have a tool here that can be useful for putting a sketch on top of the object that might be covering it. Okay, so what we really want to do is just measure these angles. Since we already have the sketch made, we're not going to remake it, but we could if we had to, of course. So what I'm going to do is switch over to construction mode, add a line, a vertical line here. We'll make this point on the line, and when we do this, it's going to move the line over because the point is already constrained into place. 2 degrees of freedom. You have to constrain you don't have to, but to get your sketch fully constrained, you have to constrain all of your construction mode elements too, or else it won't be fully constrained. And if you don't constrain it all the way, you might expect that only construction mode objects are not constrained, but that might not be the case. So I'm going to use the symmetry constraint with 3 points. We can use symmetry constraint to constrain around edges or the axis, but we can also constrain 2 points around another point. So it can be 2 points around an edge or 2 points around another point. When you are using 2 points around another point, the order of selection is important. The last item selected has to be that central point. And then we'll apply the symmetry constraint. So now, and this doesn't really matter for this project, but this shows you how the symmetry constraint works. And one final constraint, the length of that line. And I'll just choose 80 millimeters, that'll be fine. Doesn't matter. So the whole idea of this line is so we have something to measure these angles against. Could have used the vertical axis, but I want to show you how to use construction mode elements. So oftentimes I'll show ways of doing things that are not necessarily the best way or the easiest way. There's always multiple ways to do things in FreeCAD. I'm trying to show you the different ways, so I'm not necessarily showing you the best way in all cases. And if I think something's the best way, I might be wrong too. It might not be the best way. So now we need to measure this angle. And to do that, we can use the angle constraint. But we cannot apply the angle constraint because that would be a redundancy. Watch when we try. We select these two lines, apply the angle constraint. You see here, sketch contains redundant constraints. You cannot leave redundant constraints because it keeps the solver from working. So we cannot add a redundant constraint. But it is a way of measuring this angle because it shows you what it already is. And we could use this angle and go to the, just write it down and go to the extrude object and change that property to this. But that would not be parametric because if you change your radius later and you have this angle hard coded in, so we don't want to do that. So what we're going to do is use a construction mode angle. It's called reference mode, but it's essentially the same thing. A construction mode for constraints, and the lines will be blue as well. So we turn on reference mode. Only the constraints that take numbers, the angle, the radius, for example, the length. And now we can click our edges and apply our angle constraint. And you see we now have a reference mode angle that gives us the angle. And when we change these values here, this will change parametrically with it. So we just need a name for this constraint so that we can access it outside of the sketch. There's a bug. We double click. If we try to change the name here, it turns it back to a regular mode constraint. You see now it's a regular mode and we are redundant again. So we click it and we change it back to reference mode. So the solution or the workaround is to come down here to this left side and we can rename our constraint from here. And I'm going to call this upper taper. So now we can reference that outside of the sketch. And we'll do the same for here. And let's see if this works. Well, it gave me an angle, but it measured the wrong direction. That's not a deal breaker. We could say 180 minus this. But let's see if the order of selection matters here. Select the line and then the construction line and try it again. Okay, that did not work. Let's select the construction line, then the line, and try that again. Still did not work. Let me try the axis here. Let's see what that does. I'm not liking that either. Alright then, we'll just remember to subtract 180. Subtract this from 180. F2 to rename. We call this one lower taper. I'm not prepending with CC or something like that for constraints because it doesn't work for some reason when referencing constraints. The pop-up does not appear. The pop-up menu that we use when selecting aliases in a sketch. There's a bug somewhere. Okay, let's close this now. And let's check to see that because we modified this sketch, we did not ruin this revolve model, and it is still working. Now, let's go to the extrude object and set the upper and lower tapers. So this is from the sketch object, sketch.constraints dot upper taper. Notice it's telling me it did not give me the list that we would expect it to give us, but it is working. And now the lower taper, the sketch dot constraints dot lower taper. Of course, we need to subtract that value from 180. Oh, what's this? Unit mismatch. The reason we're getting this is this a degree. It's an angle in degrees, and 180 is just a number. So there's a unit mismatch. So let's see if, yes, 180 deg for degree minus, and we need that to be a negative angle, so we can say times minus 1. That did not work. Let's see, maybe plus here. What am I doing wrong here? 360 minus. My brain is not working today. I want that to be negative. There we are. There we are. Okay. enter. Okay. Now looks like it looks pretty good. So what's next is to copy the inner. I guess we can delete this object, hopefully without destroying everything. Did not need to, I guess. Duplicate now. Yeah, that was a mistake. We need that. We need this. Let's clear these errors. We're going to need that because we're going to need to set our copy to the inner. Always remember this useful undo tool here. So let's duplicate the extrude object. We don't need anything but the extrude object. Copied. Okay, now extrude 1 contains all of these things set, so we don't have to go through all this again. We just need to change outer here to inner. Where's our inner sketch? So we're telling extrude 1 to use the inner sketch as the base, the one I deleted foolishly. Alright, now we should be able to do a cut. Cut the inner from the outer. And that looks pretty good. And hide this sketch. Compared to the revolve, they're in a different location, but they're the same. Same size. So we're at 37 minutes now. That's pretty long for a video, but hopefully you learned a few things. And there's always multiple ways to do things in FreeCAD. One of the strengths of the program. Sometimes one technique just does not work. It looks like it should, but maybe there's a bug somewhere. Maybe there's some seam lines can sometimes cause a problem. Two seam lines converging. Coplanar faces can cause problems. And you can have some problem, for example, with the revolve, and it's just not working. So knowing how to do it from a different way, a different tool. For example, using the extrude instead. Just knowing all the different ways can help you get your project done. So this is going to be it for today. Thank you for watching, and as always, have a great day.